This is how Trabant cars were manufactured in communist East Germany. With almost no changes, this reliable car was produced largely by hand by factory workers. So, welcome inside Sachsenring Automobilwerke Zwickau, where the famous Trabant 601 was produced for over 30 years. Right now, you're watching how the manual fitting and quality control of the Trabant were carried out by skilled factory workers. Since the Trabant body was made from Duroplast, these inspectors could easily refit the car body by hand using simple tools and hammers. During the 1980s, an incredible 20,000 workers were employed inside this factory, and there was minimal automation in the production process. This Trabant 601 was the third generation of the Trabant series made by Sachsenring in East Germany, and was produced from 1964 until 1990, the longest production run of any Trabant model. Between 1957 and 1991, approximately 3.7 million Trabant cars were built, including all variants. It became the most common car in the German Democratic Republic and a symbol of everyday life in the Eastern Bloc due to its ubiquity and distinctive design. The factory wasn't just assembling cars, it was a whole ecosystem: stamping, engine production, bodywork, painting, and even parts of plastics production for the Trabant's famous Duroplast body. Many East Germans remember it as a massive, buzzing industrial complex, where entire families sometimes had multiple generations working under the same roof. In East Germany, waiting times to receive a new Trabant could exceed 15 years. Yet for many families, it represented freedom, the chance to travel beyond their hometown, and eventually, in 1989, to cross the Berlin Wall. This is how the Trabant's body in white was made. Workers pressed Duroplast sheets into pre-shaped body panels using large molds under heat and pressure. Each panel, doors, hood, and fenders, was molded separately. Production in the Trabant plant was labor-intensive and hands-on. Historic footage and accounts show workers assembling parts manually and performing quality control with simple tools and direct inspection. The lack of automation was partly due to economic constraints and partly due to the planned economy priorities of the DDR, which focused on supply over innovation. The fabrication and assembly of the Trabant body were split between two plants. The Zwickau plant produced and primed the main bodyshell and chassis, while the Meerane carrosserie work handled many of the finishing tasks, including mounting panels, installing glass, wiring, and fitting interiors. Parts were regularly transported by truck between the two facilities, which led workers to joke that it was the longest production line in the world. Special trailers were used to carry multiple body shells between locations, often hauled by IFAW 50 trucks. As I've already mentioned, the Trabant was mostly made from Duroplast. Right now, you can see the process of shaping Duroplast into the individual body parts. Unlike traditional steel, Duroplast was a thermosetting plastic made primarily from recycled cotton waste from the textile industry and phenol-formaldehyde resin. This eco-friendly mix not only saved on scarce steel in East Germany but also produced a material that was light, strong, and rust-proof. The production process was surprisingly hands-on. Workers would mix the fibers and resin into sheets, which were then pressed under high heat and pressure in huge molds to form the body panels, all individually shaped. Unlike steel, Duroplast couldn't be welded, so panels were bolted or riveted onto the steel chassis. Many Trabant bodies were literally made from old cotton rags and leftover textiles, making it one of the first examples of large-scale recycled automotive plastics. Unlike conventional cars, the Duroplast bodies never rusted, which is why so many Trabants have survived in pristine condition decades later. While dent-resistant, repairing cracks required special techniques using more resin and fabric layers, more like sculpting than typical bodywork. During cold winters, the material remained surprisingly resilient. Some Trabants even survived sub-zero temperatures without panels cracking. A Duroplast body made the Trabant extremely light, giving its tiny 26 horsepower engine decent performance for its size. Thanks to Duroplast, the Trabant was definitely not one of the safest cars, quite the opposite, in fact. Right now, you're watching the engine manufacturing process from start to finish. Despite its basic two-stroke design, the engine was produced in large numbers with a high degree of uniformity, reflecting the industrial approach of East Germany at the time. Engine blocks were made from cast iron. Molten iron was poured into molds and cooled to form the basic structure. After cooling, the blocks were carefully machined to precise tolerances, ensuring the cylinder bores and mounting points were accurate. At its peak in the 1970s and 1980s, annual production of the Trabant 601 reached well over 100,000 units per year. Its production legacy lives on in museums and enthusiast communities worldwide as an example of resourceful engineering under constraint. Work was divided such that bare chassis and floor sections were prepped and primed in Zwickau, then shipped to Meerane for welding in the Duroplast panels, final priming, painting, electrical fit-up, glazing, interior trim, and final assembly. Although the exterior of the Trabant 601 stayed largely the same for decades, engineers did experiment with new technologies behind the scenes. Prototypes featuring Wankel rotary engines, diesel versions, and other advanced designs were developed in the Zwickau workshops. Some even reached the prototype stage, but none went into full production. Historians and former factory workers often attribute this to political and economic decisions. The East German leadership focused on keeping production numbers high rather than investing in modernization or technological improvements. The basic shape of the Trabant 601, produced from 1964 to 1990, remained largely unchanged, with only minor cosmetic updates like redesigned grilles, headlights, taillights, and trim, as well as some improvements in corrosion protection on certain models. The classic two-stroke, two-cylinder engine remained, but small adjustments were made to improve reliability and emissions. There were experiments with diesel engines and Wankel rotary engines, but these never reached mass production. Seating, upholstery, and dashboard layouts were gradually updated. Later models received slightly better heating and ventilation systems. Some improvements in sound insulation were made, though the car remained noisy. Right now, you're watching how manual painting of the Trabant was done. A thin primer coat was applied to improve paint adhesion and slightly protect against corrosion. Workers used spray guns to manually apply the base color coat. Because automated spray booths were not widely used, the process relied heavily on skilled painters to ensure an even coat. Multiple thin layers were applied rather than a single thick layer, allowing better coverage and reducing drips. Each coat was left to air dry or placed in simple heated drying chambers before applying the next layer. The drying process was slower than modern standards, partly due to limited equipment. Seatbelts became standard in later years. Some improvements were made to lighting, mirrors, and braking systems. Suspension and steering were refined slightly for better handling. Minor electrical system upgrades, like better wiring and upgraded lights, were introduced. Next, the interior of the Trabant was carefully fitted out. Workers installed the seats, ensuring they were securely mounted and properly aligned for driver and passenger comfort. The dashboard was then put in place, followed by the steering wheel, pedals, and associated linkages, making sure all controls were functional and correctly positioned. After the main components were installed, the electrical system was carefully wired by hand. This included connections for the headlights, taillights, turn signals, ignition system, and all dashboard gauges, with technicians checking each circuit for reliability. Heating and ventilation units were added to provide basic climate control, and finally, the interior trim, door panels, upholstery, and finishing touches was installed to complete the cabin. The process emphasized precision and manual craftsmanship, with each step carefully performed to ensure that even though the Trabant was a simple car, the interior assembly was solid and functional. This is how Trabant was driven onto a chassis dynamometer, which is essentially a set of rollers that the car's wheels sit on. This allowed the engine and drivetrain to run under load without the car moving. Before testing, technicians ran the engine to reach normal operating temperature, ensuring accurate measurements for power, fuel consumption, and emissions. If readings were outside specifications, mechanics adjusted carburetors, ignition timing, or other engine settings to meet quality standards. Each completed Trabant was subjected to a thorough series of inspections to ensure it met quality standards. Technicians tested the engine and transmission to confirm smooth operation and proper performance. After final assembly, the Trabant was moved into a special water test area. All windows, doors, and seals were closed, and the car's underbody and engine compartment were checked for proper fit. Small leaks were fixed immediately. Workers would reseat seals, adjust door frames, or apply additional rubber gaskets. The process was meticulous because even minor leaks were unacceptable for customer satisfaction. The braking system was checked for responsiveness and safety, while the steering and suspension were carefully evaluated to ensure stability and handling. The electrical system, including lights, ignition, and dashboard instruments, was also examined for correct function. Any minor issues identified during these checks were corrected, with adjustments and touch-ups made as necessary before the car moved on to the next stage or final delivery. This is what the Sachsenring Automobilwerke Zwickau factory looked like from a helicopter's point of view. That factory wasn't just a single building, it was a sprawling industrial complex that dominated parts of Zwickau. At its height in the 1980s, it covered hundreds of thousands of square meters. Despite its size, production was remarkably low-tech. Most processes relied on manual labor rather than robotics, and materials were transported between Zwickau and nearby plants. Chimneys and exhaust stacks from painting and resin curing could be seen from kilometers away. The Zwickau plant wasn't just a car factory, it was a symbol of East German industrial pride and ingenuity, producing millions of Trabants over 3 decades. The current process you are viewing is Wartburg manufacturing process in the 1980s. That was also a brand of automobiles produced in East Germany, similar to Trabant. The Wartburg 1.3 was the final model produced by the Wartburg brand in East Germany and represented a significant attempt to modernize the aging line of cars before German reunification. Domestically, it served as the standard vehicle for all government transportation and was occasionally used as a police car by the Volkspolizei. With its forward center of gravity and front-wheel drive layout, the car exhibited the characteristic handling of front-wheel drive vehicles, often showing pronounced understeer, particularly on wet roads. The traditional two-stroke, three-cylinder engine was replaced with a four-stroke, 1.3-litre Volkswagen engine from the VW Polo and Passat family. This new engine produced around 62 horsepower, offering a significant improvement over the old two-stroke units. It also delivered better fuel efficiency, smoother performance, and lower emissions. The car continued to feature front-wheel drive and a manual gearbox. Based on the Wartburg 353 body, with minimal exterior changes, mostly front grille, headlights, and some interior updates. Interior saw modest improvements in comfort and trim to match Western standards. Body still made from steel panels, keeping the solid construction of previous Wartburgs. Relatively low production numbers due to political changes and the impending end of the East Germany. Sold domestically in East Germany and exported in limited numbers to other Eastern Bloc countries. Did not achieve significant commercial success because of competition from Western cars entering the market after 1989. The Wartburg 1.3 marked the end of the Wartburg brand as an East German car manufacturer. Represented the transition from two-stroke to modern four-stroke engines for GDR cars. After 1991, the Eisenach plant was taken over by Opel, ending Wartburg production entirely.
Versehen.
The Wartburg 353 had a steel body, unlike the Duroplast Trabant. Body panels were pressed in large hydraulic presses, producing doors, hood, trunk, and fenders. Workers trimmed, smoothed, and inspected each panel before moving them to the assembly line. Panels were pre-treated with corrosion protection and primer coats were applied. Steel chassis were produced separately, including floor panels, engine mounts, and suspension mounting points. Suspension components, including front wishbones, rear leaf springs, shock absorbers, and steering linkage, were partially pre-assembled. Braking systems were prepared, including master cylinder, brake lines, and wheel cylinders. Painted body shells were lowered onto pre-assembled chassis and securely bolted to the frame. The engine and transmission were installed as a unit, with drive shafts and linkages connected. Interior components, including seats, dashboard, steering wheel, and pedals, were fitted, followed by manual connection of electrical wiring for lights, ignition, and dashboard instruments. Heating, ventilation, and interior trim were added to complete the cabin, and exterior trim, bumpers, mirrors, and lights were attached to finish the assembly. The Wartburg automobiles were built at the Automobilwerke Eisenach, an historic and long-running automotive factory in Eisenach, Germany. The plant began as Fahrzeugfabrik Eisenach, founded in 1896 by Heinrich Erhardt. It initially made bicycles, guns, and then early motor cars, becoming one of the earliest automobile manufacturers in Germany. After the war, the factory was nationalized under the Soviet occupation and became part of the East German state-owned industry, eventually reorganized as Automobilwerke Eisenach. Over its life as a state-owned manufacturer, they produced roughly 1.6 million vehicles, making Wartburg the second best-selling car brand in the former German Democratic Republic after the Trabant. The factory was a vertically integrated facility typical of planned economies, meaning many parts and sub-assemblies were supplied from within the broader state industry. After German reunification, economic pressures and competition from Western cars led to the end of Wartburg production in April 1991, with the last car coming straight off the assembly line into a museum. The original Eisenach factory site was then acquired and modernized by Opel, which established a new plant in the area to continue automobile manufacturing up to the present. Many Wartburg owners describe the car as reliable and enduring, especially considering the era in which it was built. Some owners reported cars running for decades with relatively few serious breakdowns when maintained properly. A recurring theme in user feedback is that with consistent and careful maintenance, Wartburgs could serve their owners well and rarely left them stranded. One reviewer noted that their Wartburg started reliably even in extreme cold without preheating, something that impressed drivers compared to contemporary cars. Wartburg engineering was simple and robust, meaning that many components were easy to repair or understand even for amateur mechanics. Reviews often note that parts were easily accessible and the car's design was straightforward, making maintenance and repairs less complicated. This simplicity also made Wartburgs favorable among enthusiasts who enjoy working on their own cars. However, some owners point out that late production quality suffered a bit, with occasional electrical issues or modest weld quality, typical of a car built under constrained resources towards the end of the factory's life. Like many cars of its time, Wartburgs had weak spots, such as noise from the body structure, mediocre fuel economy, and a tendency to lean in fast corners. Rust and corrosion were common concerns, especially as the cars aged, a problem many old-timer owners had to manage. Some owners also mention periodic replacements of consumables and routine parts, rubber hoses, bushings, which are common on older vehicles. Wartburgs have a mixed reputation historically, not because they were fundamentally bad, but because they were built under the constraints of a planned economy, with less investment in modern production methods compared to Western manufacturers. Enthusiasts often appreciate Wartburg for its honest mechanical feel, meaning parts were big, accessible, and straightforward, even if they weren't precision fit like in higher-end cars. Many owners stress that while Wartburg wasn't a world-class competitor to Western cars of the time, like Skoda, Fiat, or Volkswagen, it was solid and dependable for what it was and excelled in ease of upkeep. Today, Wartburgs are classic cars with a cult following. Enthusiasts often buy and restore them, noting their historical charm, spacious interior, and mechanical simplicity. Some preserved Wartburgs still run reliably on the road and are valued as nostalgic and collectible vehicles. The engines were mechanically straightforward, with fewer moving parts than modern designs. Simple layouts, such as the 1.3-litre four-cylinder, reduced the likelihood of problems and made maintenance easier, even for amateur mechanics. While earlier two-stroke engines were lightweight and had fewer components, they required more frequent upkeep, whereas the four-stroke upgrade greatly improved durability and longevity. Components such as cylinder blocks, pistons, and crankshafts were built from durable materials and often over-engineered for long-term reliability. Cast iron blocks, used in many models, resisted warping and wear, helping engines remain functional for decades. The valve train and timing systems were simple and mechanically robust, minimizing the risk of major failures. Wartburg engines were easy to access, making routine maintenance straightforward. Owners could replace belts, gaskets, and minor components themselves, which reduced downtime and contributed to long-term reliability. This practical serviceability was a major factor in their reputation among Eastern Bloc drivers. The older Wartburgs had two-stroke, three-cylinder engines, which made a very distinctive buzzy, high-pitched sound. Enthusiasts jokingly called it a buzzing bee on wheels, and anyone behind you in traffic could instantly tell a Wartburg was coming. But now back to the production process of the Trabant 1.1 in the early 1990s. The Trabant 1.1 was the fourth and final production version of the famous East German Trabant series, built by Sachsenring Automobilwerke Zwickau. Production ran from May 1990 until the 30th of April, 1991. Because demand for Western cars grew rapidly after reunification, there was less need for massive Trabant production, meaning the Moselle plant produced Trabant 1.1 alongside VW models but did not operate at the originally envisaged scale. In total, about 39,000 Trabant 1.1 cars were made between 1990 and 1991, making it the rarest Trabant ever produced. Production figures from German sources show that more than 27,000 units were built in 1990 alone, including both limousine, saloon, and universal, estate, body styles. Many of these cars were exported to neighboring markets like Poland and Hungary, because demand in a newly competitive German market was weak. The Trabant 1.1 used a 1.0 for 3L four-cylinder water-cooled four-stroke engine made under license by Barkers, based on the VW Polo motor. Power was around 4041 PS, a significant improvement over the old two-stroke units. The car retained front-wheel drive and a 4-speed manual gearbox. Its body structure still used the classic steel frame with Duroplast outer panels, a hallmark of Trabant production since the 1950s. The 1.1 was a last-ditch attempt to modernize the Trabant and extend production, but it was too late to change its commercial fate. Many potential buyers preferred contemporary Western cars that offered better quality, comfort, and performance. Opinions from owners and reviewers about the Trabant 1.1 are a mixed blend of historical respect, appreciation by enthusiasts, and criticism for its performance and outdated design. Many agree the Trabant 1.1 was a genuine technical improvement over the earlier two-stroke models, especially because of the four-stroke Volkswagen engine, improved suspension, and better brakes, which made the driving experience more pleasant and usable. Test drives note that the water-cooled Volkswagen engine and modern McPherson front suspension made the car feel closer to a Western small car of the era, smoother, more stable, and with significantly more power than its predecessors. The interior was updated and the driving position and steering feel were generally acceptable for such a simple car, and many enthusiasts enjoy the classic design and mechanical simplicity. Today, as a historical vehicle or classic, the Trabant 1.1 is often appreciated for its nostalgic value, quirky character, and simplicity, even by people who wouldn't call it a good car by modern standards. Compared to West European cars available at the same time, the Trabant 1.1 was still slow and modestly powered, with a top speed around 125 km per hour and slow acceleration by modern standards. One data summary of comments from car forums showed many negative remarks, giving the car a poor overall rating, about 1 star out of 5. Often citing sluggish engine performance and outdated technology. Although better than the two-stroke version, the layout still faced compromises: fuel tank placement under the luggage floor, no power steering, and classic Trabant quirks like a buzzier cabin feel. Reviewers and historians continue to stress that even with improvements, the 1.1 was essentially still built on very old underlying architecture dating back decades, which limited how competitive it could ever be. Its short production run, combined with reunification-era market changes that pushed most cars out of circulation, makes surviving examples relatively scarce. The Trabant 1.1 represents the final evolution of the Trabant line, transitioning from the old two-stroke technology to a four-stroke engine. It's seen as a symbol of the end of East German automotive history and a snapshot of industrial change during reunification. Enthusiasts enjoy its mechanical simplicity, Duroplast body panels, and quirky classic Trabant feel. It's also easier to maintain than a Trabant 601, since the VW-based 1.1 engine is more reliable and parts are sometimes easier to source.